Hello everyone, this is Professor Chan from Math 1245 speaking. Today we're going to be going over section 4.5, the last section. Let's just get started. So 4.5, essentially you have word problems for the following. Word problems, and it's dealing with exponential growth. The most common formula you're going to be using, actually the formula you'll be using the entire time is this one. There are kind of some small variants, it's just that the letters change. So, right, you have A to A naught E K to PT. The most common one I use is I do A is equal to P E to the KT. We'll talk about what they represent here. Okay. So K is some constant number. Okay. Um, T is your time, generally. P is your initial amount. And A is your new amount. Okay. So sometimes they'll just give you a problem like this where they give you a formula like the following. So it says the following: the size P of a certain insect population obeys the following model. Determine the number of insects at T is equal to 0. Okay. So they'll ask you, sometimes they'll give you a formula, they'll ask you to evaluate it. Should be pretty straightforward, right? All we're doing is we're plugging 0. So I have 500 e to the 0.002 times t, times 0. This becomes 500 e to the 0, which just becomes 500 times 1, which equals 500, okay? And this 500 actually represents here, this is your what's called your initial amount. So the idea is actually you're starting off, we have 500 insects for the following here, okay? Okay, so let's also talk about this right here. What is the growth rate of the insect population? It's going to be 0.002. So it's always a number next to t. Okay. Yeah, so k is also what's called your rate. So I say 0.02. Okay. Okay, so it says, what is the population after 10 days? So all we do, right, is we just plug in 10 for 500. Sorry, 10 for t. Okay, so that's 500e to the 0.2. Okay, you can actually throw all this in if you want. So I say 500e raised to the 0.02, and you get approximately 510. We'll round up, right, because we're talking to the nearest insect. So we say there's 510 insects here. Okay. So the next ones here tend to be a little bit more tricky, and this is going to be a common theme you'll be asked to find. So example, part D says, when will the insect reach 800? Okay, so what you're going to do is, right, the 800 represents the new amount. So what I'm going to do is I'm going to say 800 is equal to 500 e to the 0.02t, okay, for the following. So what I'm going to do is I'm going to solve for t, okay? Now remember, right, I could take the natural log or the log, but remember, right, we can't do that if we have a number out in front. So if I have a number in front of my e or whatever my base is, I have to get rid of it. So I'm going to divide both sides by 500 on both sides. You can leave it as a fraction on the left-hand side, so we'll say 8/5 is equal to e to the 0.02t. Okay. Now I could take the log of both sides, right? Which is fine, right? I'll actually still get the same thing, but it's a lot easier for me to do natural log. And the reason why, remember, is if I take the natural log of both sides, I don't even need to worry about bringing the exponent down, because remember what happens here is my e will cancel my natural log. So I'm left with this. Okay. And then we'll divide both sides by 0.02, and then you can throw it all in your calculator right here. Okay, so I get approximately 23.5 years, or sorry, days. Yeah, be very careful with your units. So t is equal to 23.5 days for the following. Okay. Yeah, and if they ask you to round the nearest, right, just make sure you follow suit for the following. Okay. So let's do another type of problem. Okay, so I want to kind of show you a problem like this right here. Yeah, let's do number 3. Okay. So probably the most common type of problem 4.5 is, if you notice, they will not give you a function, okay? So you have to create one yourself, right? And this is going to be a common thing, right, in section 4.5 and just in college algebra in general, right? They won't give you a formula or they won't give you a function. You have to kind of model it yourself. Now, because we know this is definitely an exponential growth, we're going to use the a is equal to p e to the kt, okay? Okay. Also remember the following here, okay? So if you want to construct your formula, or not formula, your function, look back up here, okay? So the problem that we did, number 1, notice that everything is a number except for my k and my p, right? My p is my original amount, right? That's what we should be given, and I should know my constant rate. So remember, k is a constant number. It should always be that number right there, okay? So I do know that I'm given 500 bacteria, so I can clearly see that's my p, okay? The problem is I don't know my k, okay? So we're going to do the following right here. So it says 800 after 1 hour. How many will be present after 5 hours? Okay, so, okay, for the following here. So we do know, now here's the thing, this part here is kind of irrelevant, okay? We're going to ignore that because that doesn't really matter, right? So we're going to find my function first. So I'm going to do the following here. So I also know there'll be 800 after 1 hour. That's actually my a, and then t will be 1, right? So I'm going to do this. So I'm going to say 800 is equal to 500 e to the k times 1, or known otherwise e to k. So same thing, I'm going to solve for k. So I'll first divide 500 by both sides. So that is 8/5, which is pretty familiar since we had 8/5 last time. And then I'll take the natural log of both sides. This cancels. I'm left with k is equal to natural log of 8/5. Let's put this in our calculator here. Okay. You can round it to 2 places. I'm going to talk more about this constant later. Okay. So your constant, you can write it as exact or you can write it as approximate. Both generally should be okay, but there are sometimes you do need to write it as exact, okay, for the following. So then I can rewrite it and I can say a is equal to PE 0.47t, okay? Okay, so If I want to answer the question, right? Oh, my apologies. I forgot to put the 500. It's going to be like this. So you're going to have the following. So it says how much will be after 5 hours. So I plug that in for t. So I have a is equal to 500 e to the 0.47 times 5. Okay, I can throw all this in. Just be really careful when you do so. So I will get 5,052.42.78. Okay. So now this function is important, right? Because sometimes they'll have additional questions and you'll need your function to help you out. So it says, how long are there until there are 20,000 bacteria? Okay. So I'm going to do the following. I'm going to set 20,000, right? Because that's what I want to go up to. And then 500 e to the 0.47 t. So I'll divide both sides by 500. Remember, yeah, so always remember you cannot take the natural log or the log until you have the base by itself. You can't have a number in front of it. So now what I'm going to do is I'm going to take the natural log, both sides. Okay. Put in my calculator, and I should get 7.84 hours. And that's my final answer right here. Okay. You want to make sure you know what to plug in for what too. So as long as you know that, right? Notice I'm not putting 20,000 for t, right? Because I'm not talking about 20,000 the new amount of bacteria. It does not represent the time. Okay. 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 So let's look at another example. Okay. So you're going to see stuff like doubling time and half time quite a bit. Okay. So this is going to be kind of an interesting problem. So it's kind of like what we did last time. Notice they don't give us a function. So you have to create one yourself. So you have a is equal to p e to the kt. Okay. Notice they also don't give you your k. Okay. So their first step is you want to find your rate. Okay. And then you'll actually answer the question. So the problem is, like, right, you can't really answer a lot of these questions if you don't have the function to begin with. So we're gonna create our function, right? In this case, which is a is equal to p e to kt. So 10,000 is p. E k is we don't know. Okay. Now, it says it doubles in size for 18 months. Okay. So I'll put 18 for t. And then I'll also put 20,000, right? Because if it starts with 10,000, it will double to 20,000. So I'm going to divide both sides by 10,000. And then you'll take the natural log of both sides. divide both sides by 18, right? Okay, and then k is approximately 0.0385. So we're going to go 4 places. Okay, let me just double check in my calculator. Yeah, 0.0385. Okay, so what you're now going to do, right, is you're going to rewrite your function, because now we have a k that we know. And then we can answer the question, right, 2 years from now. Be really careful because we said t was 18, so we're talking about in terms of months. So that means we'll convert this to 24, right? Because there's 12 months in a year. 12 times 2 is 24. Okay. So I'll multiply my two exponents together. And I have 0.924. And then you can throw this in your calculator right here. I would recommend too to try to show your work. I know this part feels easy, but if you do mess up, I would have a hard time kind of following you. So you do want to kind of slow down a little bit, but round in nearest person. So I have 25,193 people. Okay. So let's talk about the following here. I'm gonna go to number 6 here. Okay. So you will also have something called half-life. So what is half-life? Half-life is the opposite of doubling time. Okay. So let's kind of understand what's happening, right? So you're still going to use the A is equal to PE to the KT, okay? For the following here, okay? So it says, after release of the radioactive material, the hay in Austria was contaminated by a half-life of 8 days. Is it safe to feed the cows when 10% of 131 remains? How long did the farmers need to wait to use the hay, okay? So once again, you do need to find your function. Now this is where it gets a little odd, right? Because you're like, that's strange. We don't have an initial amount, and we don't even have a final amount. There's a lot of things we don't know. The only thing we know is k, right? Because that's 10% or 0.1. Okay? So this is going to be the following. It's going to be A is equal to PE to the KT. Okay? So I do know my k is 8, and my t is going to be t here. Okay? Or sorry, I actually don't know. Whoops, sorry. My apologies. We actually don't know the 10% here. Okay. So my apologies right there. Okay, so my bad. Let me re-explain again. So t is actually going to be 8. We actually don't know k. Okay? Now, here's a situation at hand, okay? I don't know my initial amount, and I don't know my final amount. But I do know after 8 days, it's going to cut in half, right? That's my half-life, okay? So you can just make up any number. The easiest is always use like 100 or like 10, okay? So I would say if I'm starting off with 100, right? That means my new amount will be cut into 50, right? It's been cut in half, okay? So I have the following here. And I'll divide both sides by 100. Right, always get rid of the number before you take the natural log. Okay, we take the natural log because we want to get rid of this e. Now we'll divide both sides by 8. So I'll throw this in my calculator. So I get negative 0.0866, okay? Here's a thing, okay? If you are talking about half-life or something is decaying, you should have a negative k, right? Because it should make sense because it's decreasing over time. If you're doing population, your k should be positive here. Okay? So now I have my formula, right? I'm going to do A is equal to P e to the negative 0.0866 t. Okay? Now it says how long will the farmers need to wait when it's 10%? So what I do is if I'm starting off with 100, well, what's 10% of 100? That's just going to be 10. Okay? Then I just kind of divide by 100. Right, I'm going to solve for t. Remember, I'm dividing by 100 because I don't want a number in front before I take the natural log. So I'll take the natural log of 0.1 and natural log of all this stuff here. So remember, the e cancels out based off our rules of logs. And it's 26.58. And we're talking about days. Okay. So let's do one last one. And again, if you have questions, feel free to let me know. So let's look at number 7, okay? So the fossilized leaf contains 70% of its normal amount of carbon-14. Find how old the fossil is with a half-life of carbon-14 of 5,700 years. So once again, we don't know how long it takes, right? We actually don't know how to do this because we don't have our function, so we need to create it from the start. Okay? So let's talk about this. The 70% I'm not going to be able to answer. However, I do know it has a half-life of 5,700 years. Okay? So what I'm going to do is I'm going to kind of pretend if I'm starting off with 100, I'll end up with 50 after 5,700 years. And then I'll solve for k. Okay? So divide both sides by 100. Okay? So let's talk about this one here, okay? You'll find something odd, right? So if I put this in my calculator, okay? And you can have this happen quite a bit. So I have something like this, right? Which is a really tiny number. If I add 1, so it's really negative point. Yeah, actually, no, I don't want to do that. Okay. So, and this can happen because you can have a k that's really tiny. This is actually negative 0.000121, right? You can write that. The problem is, right, it's going to be kind of tedious, okay? So sometimes you want to write it in this form. So you're going to write it like this. Natural log of 0.5 over 5700 just stays like that, right? And this is called the exact, right? This is your exact answer, right? The ones we had that was in decimal form is called approximate, okay? And so sometimes you are forced to do exact, okay? Because, because, right, if you put in your calculator, it's really tiny, okay? So let's talk about this here, right? So you need to understand what does having a half-life of 5700 mean, right? So we're saying every 5700 years it's cut in half, right? So the idea is if I have, right, 100 carbon, after 5700 years, it becomes 50%, right? After another 5700 years, oops, sorry. It becomes 25, and after another 5700 years, it's 12.5. Okay? And it keeps going, okay? So notice they're asking us how much, what would be the amount be if it's 70%, right? Now let's think about it. 70% is like right here. So you can kind of visually see this diagram. Does everyone see that? Okay, so the idea is when I calculate my answer, right, it'll probably be, so since it takes 5,700 years, right, to go to 50%, it'll probably be less than that. So if I had to guess, probably be like, maybe like 3,000, right? Maybe 3,000 or like 30, like low 33, like maybe 3,300, just because it's a little bit more than half, okay? So it's a little bit more than halfway from 100 to 50, okay? Or for example, they ask you like what percent or how long it'll take to go to 25, right? It'll actually be 5,700 plus 5,700, right? Because it takes 5,700 years to be cut in half twice, right? So it'll be 11,400 to go to 25, and then 17,100 to get to 12 and a half, right? So every 5,700 years, it cuts in half. And so this is a good visualization of kind of seeing what happens as we go on, okay? So I should, when I do my answer, it should kind of make sense based on the diagram that I see, okay? So I'm going to do A is equal to PE to the natural log of 0.5 over 5,700 over T. So let's talk about this here. So my A, since I want it to be 70%, I'll make it 70. I'll make my P 100. Okay. We're going to divide both sides by 100. So I have 0.7 e to the natural log of 0.5 all over 5,700 times t. And then what we're going to do is we're going to take the natural log of both sides. Okay, I know the right-hand side looks really weird, but it's going to be, it'll clear things up once we take the natural log. So remember, this natural log will cancel with this e, right? That's what happens. So then I'm left with natural log of 0.5 all over 5,700 times t. Okay, how do I get rid of this, right? I will multiply both sides by 5,700 and then divide by natural log of 0.5, right? I multiply by my reciprocal. Right, so this cancels. So I have t is equal to the following. Let's throw this in our calculator. So I'll multiply first. And hey, look at this, right? We got 2933. What did I say? I was like, oh, it was probably maybe like the low 30s, like low 3000s, right? And we're pretty close, okay? So you can kind of visualize your problem before you get to your answer. And then your answer can kind of like confirm with if you're in the ballpark or if you did something completely wrong. Okay, right? So if I got like 20,000, I'm like, there's no way that's possible, right? That'll be probably less than 5%. Okay. So I have 2933 years. And once again, if they ask you to round, make sure you do so. Okay, so that is it. And we're done with chapter 4. If you have questions, let me know or post on the discussion board. But other than that, I'll see you guys later.